So now, what's the difference between multiplying and factoring? So in an earlier section, we learned how to multiply whole numbers using the distributive property and something called the partial products method. So for example, if we wanted to take 23 times 45, we thought about this 23 in its expanded form with its tens part and its one part as 20 plus 3 times 40 plus 5. Okay. And in that section we had looked at how to distribute this entire group to 40 and then again to 5 and then redistribute, and then eventually we got 4 terms in this expression. Okay. And then later we looked at how we could also, with the pictures, we thought about this as 20 plus 3 and 40 plus 5. So we had actually had all the rows of the blocks. And so here we had 40 rows of 20 blocks, which gave us 800 blocks altogether. But this row was actually 23 long, so then we had 3 more blocks, and we had 40 of those. So 40 groups of 3, we had 120. 20 groups of 5, we had 100. And 3 groups of 5, we had 15. And so as we looked at, 45 rows that were each 23 units long, to figure out what this product was, then we can just add up all these partial products. So this was called our partial products method. And so we get 800, 900, 1,000, and 35. Okay. So now, again, many of you were eventually taught how to multiply these numbers with some sort of algorithm where you would take 5 times 3, and you were told to write the 5 and carry the 1, and then you'd do 5 times 2 is 10, and then you'd add the 1 and get 11, and then you would put a 0 for some unknown reason to most students, and then we'd do 4 times 3 was 12, we'd put down the 2, carry a 1, 4 times 2 was 8, but then we'd add the 1 and get 9, and then we'd add these. 5 plus 0 is 5, 2 plus 1 is 3, and 9 plus 1 is 10. Okay, so 1, most students don't do this process correctly, and 2, they don't understand why this 0 is here or why we carry this 1 here and so on. Where the partial products method makes complete sense where all of the numbers come from, and it extends very nicely to algebra. So now let's think of this quantity. It's an awful lot like what we had here, only we've got, instead of numbers initially, we've got x's. But if we map this out the same way with its terms, and x3, x plus 5, x times x is an x squared, negative 3 times x we get negative 3x, positive 5 times x we get a positive 5x, and a positive 5 times a negative 3 gives us negative 15. And so then if we add things up like we did here and collect all the like terms, we'll get an x squared. We have 5 x's and a negative 3x, so we're going to get a positive 2x and minus 15. Okay, so this is x squared plus 2x minus 15. Well, in this section we're going to learn how to factor certain types of polynomials that will reverse this process. So x squared plus 2x minus 15 we know is equal to x minus 3 times x plus 5. Okay, so how do we go backwards? So in mathematics oftentimes we talk about operations that do something and then some operation that will undo what we've just done. So like addition and subtraction undo each other, they're inverse operations. Multiplication and division undo each other, so they're inverse operations. So here, going forward in this direction, as we multiplied everything out and collected all the like terms, we were multiplying. Okay, in this section, and we'll talk a little bit later why, we're going to want to be able to take this quadratic expression and write it in an equivalent form that's easier to deal with for the particular type of question we're trying to answer. So we want to be able to figure out how we can factor this as a product of these two quantities, x minus 3 and x plus 5. So to factor a polynomial, this is another important verb in mathematics. So we've looked at simplify, evaluate, solve, and now factor. Okay, 4 very, very important verbs in mathematics. Is to write a polynomial expression as a product of these factors. So if I told you that I'm thinking of two numbers and their product is 6, is this enough information to determine what the numbers are? Okay, so again, you might want to hit the pause button and just think for a few minutes. So think about two numbers whose product is 6. And are there other two numbers that can also give you product of 6? Or is there only one pair? Alright, well, if you've just unpaused, and hopefully you paused to think for a little bit first before just listening to what I'm going to tell you the answer is. Alright, so on here, the answer here is no. Okay? So we could, these two numbers could be, 2 times 3. Okay, that would give us 6. But we could also have 6 times 1, that gives us 6. Okay, or we could even have something like 12 times a half. It would also give us 6. Okay. But what if I told you that I'm thinking of two numbers and their product is 0? Is this enough information to determine what the numbers are? So again, if you push pause and think for a few minutes and then unpause. Well, in this case, if you write down some things whose product is 0, you might think of 2 times 0, or 40 times 0, or a half times 0, or 0 times 10, etc. So there's not only one pair that will give us a product of 0. Let's put this one in here too, 0 times 0. But one thing that we should notice in here is that knowing two numbers' product is 0, at least one of the two numbers has to be a 0. Okay, so in this case, does this give us any information about the numbers? And the answer here is yes. Okay, at least one of the numbers must be 0. So that leads us to something that we're going to use in solving these types of equations called the zero factor theorem. So if A times B is equal to 0, then A is equal to 0, or B is equal to 0, or both. Okay, so if the product of two numbers is 0, we know at least one of these two numbers has to be equal to 0. So in this section, we're going to learn how to rewrite an expression like x squared plus 2x minus 15 as the quantity x minus 3 times the quantity x plus 5. And this is called factoring an expression. So when you write an equation in this form, it looks like the following. So we're going to have some factored expression n equal to 0. We're going to find it's easier to find the values that make such an equation true. Okay, in other words, it's easier to solve the equation if we can first put it in this form. Okay. Alright, so factoring is just reversing the process of multiplication. Okay, so let's start with some multiplication problems whose products will be these quadratic expressions that we've been looking at. So we've got x minus 4, x minus 3. Okay. So again, if we look at all of our partial products, we're going to get x squared, negative 4 times x, negative 4x, negative 3 times x, and negative 3 times negative 4, positive 12. So now if we collect our like terms, we get x squared minus 3x minus 4x, we get minus 7x plus 12. Okay, so x minus 4 quantity times x minus 3 gives us x squared minus 7x plus 12. Okay. So now x plus 5 times x minus 3. And if we look at all the partial products, x times x is x squared, positive 5 times x plus 5x, a negative 3x, and a negative 15. And again, once we collect like terms, we'll get x plus 5 times x minus 3 is x squared plus 2x minus 15. Okay, so again, these are equivalent expressions. Okay, so any x we plug into this side, whatever we get, we'd get the same thing as if we would plug it into this expression instead. Alright, so now 2x plus 3 times x minus 4. Again, if we write out all our partial products, we get 2x squared plus 3x minus 8x is 12. So again, if we collect all of our like terms, we'll get 2x squared, a negative 8x, and a positive 3x. When we combine, we'll get a negative 5x, so we can write that as subtract 5x and subtract 12. So again, the quantity 2x plus 3 times the quantity x minus 4 is equivalent to 2x squared minus 5x minus 12. And our last one here, we have 5x minus 1 and x minus 2. So again, if we write out all of our partial products and then collect like terms, we'll get 5x squared minus 10x, take away another x, minus 11x plus 2. So again, the quantity 5x minus 1 times the quantity x minus 2 is equivalent to 5x squared minus 11x plus 2. So again, we're going to kind of start in this section with doing something that's called a guess and check method, or a trial and error method. But if we're looking above, to get these, this 2x squared, we can kind of look at just these first terms, and to get this negative 12, we had a positive 3 and a negative 4. Okay, same thing here as we're looking at this 5x squared, we had a 5x times an x. Or to get a positive 2, we had a negative 1 times a negative 2. So we're going to use, as we're going forward, we're going to look at how, at least to begin, how to get the first and last term coefficients.